Good morning, everyone. We are the Group 4 and we're about to present our lesson for today, random variable. So, our objectives for today are, at the end of the discussion, you'll be able to first find the random variable. Second, know the importance of the random variable by giving a real-life example. And lastly, develop skills in solving random variable problem. So, yeah.
What is a random variable? A random variable is it's a variable that assigns a numerical value or characteristic to an outcomes of an experiment. The set of all values possible for a given random variable is the range space. It's also called a scholastic variable. It is usually written using a capital letter. In a probability and statistics, a random variable, random quantity, aleatory variable, or stochastic variable is described informally as a variable whose values depend on outcomes of a random phenomenon. The formal mathematics treatment of random variable is a topic on probability theory.
Initially, there were total 11 balls in the run breakup, of which being 6 blue balls and 5 red balls. 2 balls are drawn from the yarn without replacement. Value of random variable represent the number of blue balls in the yarn. So, two balls are drawn successively from the yarn. The random variable, that is the number of blue balls in the yarn, can have any of the following values. Example: if both the balls drawn out of the run are blue, then the value of random variable will be 6 and 2 equals 4, and each probability equals 6 and 6 C2 and 11 C2 and equals 3 and 11. The answer is equals 0.2727.
Good day, everyone. I am from Group 4 and I am one of the representative to discuss one of our sample problems. So here it is. I roll a fair die repeatedly until a number larger than 4 is observed. If n is the total number of times that I roll the die, find p times n is equal to k, for k is equals to 1, 2, 3, so on and so forth. So as you can see, in each trial, I may observe a number larger than 4 with probability 2/6 is equals to 1/3. So thus you can think of this experiment as repeating a Bernoulli experiment with success probability. So P is equals to 1/3 until you observe the first success. So thus n is a geometric random variable with parameter, so p is equals to 1/3, n till geometric 1/3, hence, so we have p sub n times k as 1/3 times 2/3 k raised to the power of 1, for k is equals to 1, 2, 3, and so on and so forth. That's all. Thank you.
Sample problem. Use the given table of values given to solve this example. Since x is a random variable, its sum of probability is equals to 1. So px is equals to 0 plus px is equals to 1, px is equals to 2, px is equals to 3, plus px is equal to 4, plus px is equal to 5, plus px is equal to 6, plus px is equals to 7 is equals to 1. Next is to substitute the values of px based on the given tables of values. So we know that the px0 is equals to 0, px equals 1 is equals to k, px equals to 2 is 2k, ps equals to 3 is 2k, px equals to 4 is 3k, px equals to 5 is 2k k square, and px equals to 6 is 2k square, and lastly px equals 7 is 7k square plus k. After we substitute, the next step is to add like terms. So we have now 9k plus 10k squared is equals to 1. Then arrange the terms from the biggest value to the least value and transpose the 1. That's why we have 10k squared plus 9k minus 1 plus 0. And our final answer is 10k squared plus 10k minus k minus 1 is equals to 0.
Hi, I'm discussing two types of random variable. Discrete random variable can assume a countable number of values. Example, people in your house, number of notebook inside your bag. Continuous random variable can assume any value along a given interval of number line. Example, height of a giraffe, the line of a task. Thank you.
Last sample problem. Suppose two coins are tossed. Let x be the random variable representing the number of heads that occur. Find the values of the random variable x. So, atong i-count ang total numbers of head obtained from two tosses. And ang x mo ang random variable nga nag-represent sa gidaghanon sa mga head that occur. Atong pangitaan ang tanan nga possible values sa x. So, una, butang sample space equals head, 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 tail, tail, head, and tail, tail. So, ang kani sila butang sa possible outcomes. So, ang mga result sa possible outcomes, which means the variable x, ibutang sa value of the random variable. So, ang una, head, head. So, duha man ka head, which means the random variable x. So, 2. Head, tail, usara man ka h. So, butang 1. Tail, head. So, usara man ka h. Butang 1. Tail, tail, wala may head. So, 0. So, the possible values of the random variable x are 0, 1, and 2. That's all.